Hey guys, welcome back. In this video, we will start implementing our repository pattern and setting up our project with dependency injection. Now, before we get into what those fancy words mean, repository and dependency injection, let's look at an application at the most basic level. We just set up the data classes or database objects, which allowed us to generate a database. Now, any application that is out there, whether it's a website or it's a desktop application, even a mobile app, most of these applications, especially if they interact with a database or some form of data store, they're allowing us as users to do four things with that data. It's either allowing us to create the data, read the data, or see it, view it, update data, meaning make changes to existing data, or remove data or delete. For short, the acronym for those four operations is CRUD, C-R-U-D. C for create, R for read, U for update, and D for delete. So once again, no matter how fancy the application looks, no matter how flashy it is, when you click the delete, you see an animation and all those things, no matter how flashy it looks, at the end of the day, the most basic operation is that it is removing data from the database or creating data in a database, either presenting it to you. So you click on your profile on maybe Facebook and you're seeing all the information that you previously entered. Then you're viewing the data or reading the data. If you make a change to your data, your profile on Facebook, then you're updating the data. That's it at the end of the day. So our repository pattern pretty much is a very popular pattern. It's a way of writing and structuring your code. That's what we mean when we say patterns. And it is very, very popular at the enterprise level application development. It helps us to restrict how we interact with the data and create layers around the database operations, the business logic, and the UI. So we spend some time looking at the UI, which would be modifying the look and feel, and that's the presentation to the user. And then the business logic will probably come more in the controllers when we start building out our controllers for our different modules. But right now we're focusing on the database operations, and that's really where that repository pattern is going to come into play. So I'm going to create a new folder in this project structure. So I'm just going to collapse everything that is not absolutely necessary right now. And I'm going to create two new folders. The first one, and just by clicking the project, I'm going to right click and then I'm going to say add and then folder. And then the first one, I'm going to call it contracts. And then the second folder, so I'm just going to repeat those steps, I'm going to call repository. I don't know if you were taking note, but while I had this selected, this code actually got modified as I added more folders. So you see it created two entries for the contacts and the repository folder. So we don't need to see this file really. We can close that. So the first thing I want to do is add a contract. And the contracts are pretty much the interfaces. So the repository pattern would have us create interfaces and classes that implement the interfaces. So our interface is like a template for what our class should have. And I'm going to explain that. So the first contract I'm going to create, just right click, go to add, and then I'm going to say class, but I'm not really creating a class, I'm creating an interface. So using this same pop-up box, I'm just going to select interface instead. And then I'm going to call this one repository base. All right. So like I said before, there are four major operations that every database, well, most databases or applications rather, allow us to do against the database. That's create data, view data, or manipulate the data, whether we're deleting it or making a change. So the first thing I'm going to do with this interface is I'm going to make it very generic, because every type of database table, or in our situation, data class or domain class, employee, leave allocation, leave history, they're all going to allow us or afford us the ability to perform CRUD against the records that are in these tables. So I'm going to create this base interface and I'm going to make it public. And this base interface is going to have some generic identifier called T. and then I'm just going to say where T colon class. So what this is saying is that I'm making this interface generic enough that I can pass any class in here, and that class should be able to perform whatever operations I'm going to outline. All right. So this is making this base repository generic enough, and the generic or global operations that each class or each table should be able to perform would be to create, update, delete, and view. All right. So having done that, I'm going to actually just write out the operations that should be implemented once we are implementing database operations around any class that is being passed in. All right. So the first one that I'm going to do is find all. So I'm using iCollection. So this is a generic collection class. So if you're familiar with C#, you know that C# has a number of collections. You have list, you have IEnumerable, iQueryable. iCollection is generic enough that it can almost be any of those. But then if you're not familiar with C#, then just think of it as an array. All right. So this is just saying that I am accepting any type of array of objects that might be passed in. So any type of array, that's iCollection, of type T. T would be your class, but then because I'm making T, I'm making it generic. So T here is just a generic identifier to say that any class, whether it would be leave type, leave history, can go there. And the operation would be to find all, which means I'm returning all from the database. And if you're familiar with databases and SQL, that would be like a select star from whatever the table name is. All right. So that's the find all. And then the next one to view would be to, if I wanted to see only one record, then I would probably want to find that one record by ID. So I'm creating another function declaration. Well, it's like a function header to say some class, and I want to find that record by ID, and I'm accepting some integer parameter called ID. Now, we do know that we may not have integer parameters. We may have another one, but that's fine. We can leave it as integer for now. Another set of commands would be to create, update, and delete. So I'm going to put those in, and I'm saying bool because I want an indicator as to how successful this operation was. So bool will return yes or no, and based on the yes or no, I can use my business logic to handle how the UI presents the error or success to the user, right? So I don't want to get too much into that. I just want us to appreciate what's happening as we're building out this class. So this base repository class is going to have a function to get all records of whatever class type I'm looking for, table I'm looking for. One to find a specific record based on the ID that is provided, and one to create some entity of type T. So the variable name is entity, that's generic enough. And the type is T, which is also generic, and the same for update and delete. And our final operation would be to save. Now, once again, this is all generic, and this is a base interface. So that means every other interface for any other specific table should inherit from this base, because these four operations are here defined for everybody. And then in that particular interface, if there are other operations that are needed for that particular table, then we can implement them there. So as a first act, I'm going to implement a repository for our leave type. Since that one has no dependencies, that should be the easiest one to implement. So I'm going to right click our contracts folder, go to add, and say class. But once again, we're adding an interface, and notice that the naming convention for the interfaces would be I and whatever it is. So in this case, I'm calling it I leave type repository. All right, that's my naming convention. So I'll just click add, and then when that creates it, one, I want to make it public to avoid any errors going forward. And then I can now allow my iLeave repository to leave type repository, to inherit from my base repository. So I just did repository base, right? And then remember that the repository base should have some type, some variable type being declared with it, some class type rather being declared with it, and this is generic. So since I'm dealing with the leave type repository, then I'm going to pass in the leave type as, and my autocomplete is, well, it's completing it for me, but that's not what I want. I want leave type, and I'm going to press escape this time instead of enter. So leave type is a class that I expect it to interact with. All right. And then of course it's going to give me an error because they're in different folders, different namespaces. So I just need to include that. So I just hover there, control and full stop, and then press enter. And then it will add that reference to the folder where leave type is. And then we have it now added. So that's how you go about making this interface inherit from our leave type or from our repository base. So now that I've templated what should happen, and once again, I'm trying to keep it simple because we're at the start. So this iLeave repository is now going to define the database operations that are actually implemented in our repository. So I'm going to go and create a class, and this time it's going to be a class in our repository folder. So I'm going to right click that, click add, go to class, and then leave it as class. And then I'm calling this one leave type repository. All right. And then I click add. So now I have a new class that's called leave type repository. It's blank. And the expectation is that whatever was defined inside of this repository should be defined inside of this class. Notice nothing was defined in this repository, in this interface rather, but it is inheriting from iRepository base, which has 5 functions defined, which means that we expect to, or 5 functions declared rather. And so we expect to define the behavior of those 5 functions inside of leave type repository. So the quickest way to get them in is to inherit from our iLeave type repository. And I'll explain why we don't just inherit from iRepository base over here. I'll explain that. But for now, let's just work with this. So iLeave type repository, and I'm just copying that, and then I'm going to make it inherit from that. And then once I do that, you're going to see the red line. Now, firstly, I need to include the namespace where the contracts are, and then you notice that the red line is still there. If I hover this time, it's a different arrow. It's now saying that it does not implement the interface member, and notice it's seeing all of those functions coming from the repository base. All right. So it is expecting that if I'm inheriting from this interface, that whatever functions are being declared, and once again, none is being declared here, but they're all being declared here, and repository base is being inherited by iLeave type repository. And so by inheriting iLeave type repository, it is basically inheriting the fact that these functions need to be defined. And so I can just use my light bulb once again and say implement interface, and it will just steamroll through and implement all of our functions associated with our repository base. Now let's say that there are certain functions, and this is now explaining why we're not just inheriting from the repository base. Now, these are just the basic CRUD. Once again, those are the base. Those are the 4 main functions that you will always do on any function, on any table, right? But then maybe there's a function that only iLeave type repository needs to know. So the base doesn't need to know it, because if the base knows it, then everybody else who inherits from base will also know it. So I can go ahead and define another function right here. And so inside iLeave type repository, and so when leave type repository inherits from it, it will know everything that the base knows, as well as anything that its corresponding repository interface knows. So let's say I wanted one that returned some I collection, and then because this one is specific now, it has to be of leave type. All right. So this time it's not T. There's no T within this context. So I want a collection of leave type, and then this function is supposed to get employees by leave type. right? Let's say I wanted to get all the employees who have taken a particular type of leave. And then this is going to take int ID being the ID for the particular leave type. Now that I've defined this inside of iLeave type repository, if I go back to the inheriting class, then you see the red line is there. And the error now is that I have not implemented all of the functions, and that is because it's now seeing that a function is a part of iLeave type repository. So I can go ahead and implement interface, and it will just add that function to the list of functions to be defined. So with that, I'm going to pause, and I'm going to allow you to go ahead and create the other repositories, the other interfaces and corresponding repository classes for leave allocation and leave history. I'm going to leave you to do that. I'm going to do it. I'm going to complete it so you can reference it, but I want you to go ahead and try and get a feel of doing it yourself. All right, so I hope you paused the video and tried it yourself, but I'm about to go through what I expected you to have completed. And if you didn't, that's fine. Then we'll go through it together, and you will find the resources for these created files in the resources for this video. Anyhow, what we were to do was to create the iLeave allocation repository, iLeave history repository, and the same for the actual repository classes. So if we completed it successfully, then leave allocation should look like this. Remember to put on your public if it doesn't already get generated with it. Public interface iLeave allocation repository, and we're inheriting from repository base with the appropriate class, which is leave allocation. And the same for the history. We have the same format, same pattern, just the different name, and we're sure to inherit for the right class type. All right. And then for the respective actual classes, then we're inheriting iLeave allocation repository, which we just rolled out the implementation for the interface functions inside of the class file, and we did the same for the leave history repository. Now there's one more thing, and this would be like the start of our dependency injection, or a look at what dependency injection really is. But we need to actually let these repository classes know about the database. So yes, they know about the classes and all those things, but they don't embody the actual connection to the database. And if you recall, that application DB context really embodies that connection. So this is like our gateway and our bridge to the database itself. So it actually houses all of our entity framework functions right here and the actual connection to the database. So we need an object of type application DB context, and then that will allow us to actually interact with the database. So and going back to the first one we did, which is leave type repository, in the class before our create and the implementation of all the other functions, I'm going to declare a private read only or property, and I'm going to make it of type application DB context. And then I'm going to call it, well, underscore DB. All right. So the pattern for private properties is usually I use an underscore when you're naming it, right? So that's like a nice tell that if anybody comes by, sees your code, they know, oh, underscore, that means it's a private variable or whatever in your class. All right. So that's step one. Step two is to create a constructor for our repository. So we have public the shortcut for our constructor is to write CTOR and press tab twice, and it actually generates that constructor block of code for you. So you should be familiar with OOP. A constructor is any function that has the same name as the class, and it does some initializations when that class is called or instantiated. So in this situation, what we expect this to do is to initialize a fresh copy of our application DB context variable. So you notice that it's saying that it's defined, but it's never used. So it's just there. So the first thing I want to do is actually give this a parameter, and it has to have a parameter of the same type that I'm about to initialize. So I'm just going to copy that and call it application DB context, but not underscore DB. So this one is private and this one is coming in through the constructor. And then we're just going to initialize the private one to be whatever value comes in through the constructor. Sorry. So then our constructor is now initialized to have this. So that's what dependency injection looks like. And this is step one. This is not all there is to dependency injection. It's quite a few steps, but this is the first one. So this block of code needs to be present in every repository class file. So we're just going to copy this. We wrote it once in iLeave repository. So I'm just going to copy it and I'm going to go over to leave allocation and I'm going to put it there. And what I'm going to change is just the name of the constructor, because obviously the constructor name can't be leave type repository. So I'm just going to make sure that it has the correct name. And then I'm going to do a similar thing in leave history and just change the name. And then our data classes or our repository classes are nearly ready for action. So we've done quite a bit of work setting up this framework. And once again, the repository pattern is literally that. It's a pattern, it's a structure. So if you do it with these three and you find out that you have 5 more tables you need to add, then I expect you to follow the pattern and do this 5 more times for each of those tables. It may seem tedious, but at the end of the day, it's a structure that allows you to maintain your code even better because it cuts out a lot of repetition, helps you centralize your code, and makes maintenance easier over time. All right. So right now our functions are defined, but they really don't have any functionality. They're just going to throw exceptions, and we'll leave them like that until the next video where we actually go through and define the database operations. In this video, we're just putting in the groundwork, putting in the foundation. And the last thing that I want to do is to add the knowledge of these repository files and their purposes to our startup.cs file. So we went into this file briefly and we saw that we had a configure services function that, it initializes some stuff. So I'm going to add some more initializations here, and I'll do that after the database initialization. And these initializations are to add our repository or contract and repository class relationship to the .NET Core application, right? So what I'm going to do is say services dot, and then I'm going to say add scoped. And then we have our first class, and I'm going to say I leave type repository. And then put a comma, and then I'm mapping the iLeave type repository to its matching repository class, which is leave type repository. And then I'm going to close the braces and semicolon. Now, of course, there are red lines because we need to include the namespaces. So I'll just use my control dot and include that namespace for the iLeave type repository, which is the contracts. And then I'll do the same here and include the next namespace for our repository. All right. All right. So once we add scoped and we put in our repository or interface and our repository class, then if you get any red lines, then you probably just want to check your references up top and make sure that you have the correct namespaces for the respective files. And then we're going to do that for each of our pairs. So we have iLeave type repository. We also have iLeave history repository, and we also have iLeave allocation repository. And so you see the red lines are appearing now because it's realizing that there's some mismatch between the interface being referenced and the repository class. So to clean that up, we can just make sure that we're just pairing them properly. So I'm just going to copy the name of the interface and move it over and then remove the I. And so everything is, now our startup.cs file feels much better about that. So I'm just going to add some comments here to say, so this section deals with adding references for repository and contracts to startup file. All right, so that's the comment that I added for that section. So once again, for as many other data tables that we may have. We want to create a contract for that table. We want to create a repository class for that table. So, and then you just add them in that section inside of the startup.cs class. So those are a few steps towards implementing our repository pattern. Please note that once again, all of the functions that would have been implemented are pretty much empty. They're just going to throw exceptions. So in our next video, we'll actually start putting in the data operations per class or per function rather, so that we can have some database operation baked into our application.